Okay, we're going to look at creating a fractal, which is nothing but an object that shows an idea called self-similarity. We're going to do this starting with a triangle. So you want to have a nice big triangle, and we're going to find the midpoint of each of the sides of the triangle. We can do this basically by taking the triangle and folding each side in half to find the center or the midpoint of that segment and marking that off. So we're going to do that for all three sides. So let's pause here so that you can draw your own midpoints and then check your answer. And once you have your midpoints drawn, let's connect them all by drawing what is called their mid-segments. To make this a little bit easier to talk about, I'm going to label my triangle A, B, C, and now the midpoints I will call D, E, F. Let's look at some properties about these mid-segments before we continue building our fractal. If I look at the segment DE, I notice that it never touches the side AB. So this is one of the properties is that it is going to be parallel to that side. And because also, in addition to the parallel, there is another relationship that it has. If I measure DE, and I'm just going to use a piece of paper and mark off the length of DE on the piece of paper, and I slide it down to part 2AB, I will find it matches up with its midpoint F to B, and it also matches up with the midpoint F to A. So pause here and check that your mid-segment matches up with half of your opposite side. If I were to go around to each mid-segment, I will find that these all work. FE also equals half of AC, and it is going to be parallel to AC. FD is also equal to half of BC, which it is going to be parallel to. The other thing that has happened is I've created 4 smaller triangles. If I trace one of these triangles and compare it to the other 3, I find another relationship. So pause here, trace one of your small triangles, and start comparing to the other 3. If I compare that smaller triangle by overlaying the traced one to all the other triangles inside, you will notice that it is the exact same size. All 4 triangles are the exact same size. So now I have a large triangle with 4 smaller triangles that have 1/4 of the area. So now let's go back to building our fractal. Fractal is all about similarity. So right now I have a large triangle, 4 smaller triangles that are the exact same size and would be 1/4 of the area of the large triangle. just by appearance, they look similar to the large triangle. So let's repeat the process. So now I want to find the midpoint between C and E, C and D, and then D and E. And I'm going to repeat that by doing the exact same thing of folding the sides in half. So pause here and find the midpoints of triangle CDE. Now let's create those mid-segments. Now what I start to notice is that this triangle CDE looks very similar to what I just created initially with the large triangle ABC. I have the larger triangle containing 4 smaller triangles. And each smaller triangle is 1/4 of the area of the larger triangle. If I continue this process by finding the midpoint, I will create my fractal. And I will continue to create smaller and smaller triangles that look similar to the larger triangles, therefore promoting that idea of self-similarity. And even though I've only focused in on the original top smaller triangle and just building one, you can go within each of these triangles and continue to find all the midpoints. And you will end up with a series of triangles that all look similar and are 1/4 of the area of the triangle that they're contained within. This ends the video. I'm going to do a little bit more, but I want to just take a video.